Hey, how's it going, everybody? Wanted to share this project that I've been working on, and I want to do a tutorial on it. So this is a project. It uses FastAPI, Pydantic pretty heavily, and just vanilla HTML, CSS, and JavaScript on the front end. One of the reasons I think it's really cool is just because data validation and coercion is something that I didn't really get into until recently. I've been programming just as a hobby for maybe 5 or 6 years. So I'm not a professional programmer, but it's something I've really gotten into, and it took me this long really to see how important, how helpful it is to drive your data with purpose. So essentially, this project, it's just, we're gathering information from the CPU sensors, the computer sensors rather. It gives you CPU stats as well as stats about the RAM and the disk stats. But really, what I think is kind of cool is the ability to have your data drive your application state. Let me scroll to the top here and look at the initial connection. This is this object represented as JSON. When the client connects, it sends a connection request to the server and actually receives this back. And this is a data structure that's held on the server and sent to the client. It's actually a Pydantic object. When the front end connects, the connection is sent through this connection base model, where its UUID is generated by this field here. The default factory is essentially field creation upon initialization, I guess. So we can track the client through a UUID, and we store the WebSocket with it. That way we can track its communication through the server for the lifetime of its connection. This model config here, so when you have an object in memory on the server that you want to communicate or use to communicate to the object, you can't just send that object through the network, because this is a Python object, obviously. It's not JSON, essentially. So most API calls, most API requests are done in JSON. So when the connection is made initially, we generate a UUID, which is a Python. Well, we're using Python to generate a UUID, which becomes a Python object. This default factory here is an initialization creation of the object UUID. We use that UUID to identify the client in order to have access to the WebSocket object for further communication. So if you actually look at the information that the client receives, that's the information that's generated by this model config. That's the information that's generated by this default factory, just represented in JSON. And that's a really, really powerful tool when you're using any kind of web communication. The other thing that's pretty cool, if we go down here, you can see that we describe this this data object. This is the stats payload that generates all the data points for these graphs. And that communication, if we look at this structure here, this is just a very basic representation of the data that we're going to use to graph, right? But again, you can't just send this stuff over the network. You can't just send any kind of Python object. It's not exactly trivial to represent this data that comes in Python or that's generated by Python and send it over the network to communicate through the web with a client, with a phone, with a computer, with a sensor, with anything. So again, we have this stats event base model class, and again we're using the client ID to track it. And you'll identify your client through some kind of ID, and then you'll structure your data through this event, or describe your data through this event, and then you'll structure your data in this data field here. So in the data field, we have the stats payload. Again, we have another default factory on the field, and that default factory creates the stats payload object. And that data factory uses a Lambda function to create the stats payload object, which takes the computer class and gets all of the information from the sensors on the computer. We have a timestamp field here. And then we use this model dump class here in order to generate a Python object in the server. And one of the cool things about using Pydantic with FastAPI is you can kind of do field trials with this data structure. You can create a data structure and pretty easily get access to the JSON that it creates just through the documentation endpoint. So if we go to the docs dashboard here and you look at this data, FastAPI provides a way to use its documentation to make these API requests from the browser, which is awesome. You don't have to use Postman or do any kind of weird curl requests or anything like that. we can just go to the docs endpoint and then go to our endpoint here, or URI, hit try it out and execute. And if you look at the data here, CPU count, CPU usage, frequency, all that stuff, we have all of that right here. And this JSON schema model describes what the data structure is supposed to look like, and along with some other things like validation. Like these fields are required, and it says that clearly right here. So when comparing standard REST API requests over HTTP and WebSockets, they're pretty identical in the way that they transfer state. So essentially, with a standard HTTP request, for an API, you'll have a client will initiate an HTTP request. The server processes that request. Then the server sends back an HTTP response with the status code, and the client receives and handles the response. And then the server basically closes the HTTP connection. It's not exactly true, but in effect it is. So that might look something like this. So on the client initiation, you'll have typically some JSON for an API. It'll be one of the four standard HTTP methods: get, post, update, delete. It'll hit a URL endpoint. It'll have headers. Typically, you'll secure it with some kind of bearer token or JWT or authorization, but you'll declare it. You'll declare your type as application JSON, and then the body of your API request will hold the JSON data. So this is just an example of that. And then the server will take that request and process it. That might be committing something to the database or requesting that the server do some kind of transformation on the data to send back to your client. But the server will do that. Well, first, I guess the server will actually validate your request. Let you know if you're authorized to actually make these requests. It'll authenticate that you are who you say you are and process your data and then prepare the response. And then the server will send back an HTTP response. Those have HTTP status codes typically. Not required, but it is a standard. We'll also have headers. And at that point, the client receives the handled response. And that's the end of the communication for a standard HTTP API request. The big difference is with WebSockets is that that communication line doesn't close. It stays open for the duration of the need for both the client or the server. So essentially, the client will send a message. It's typically a connection request, but this is what it may look like, just standard JSON. Usually it'll say who the client is, what kind of client it is. It'll have what the event is, if it's a message, connection, disconnect, whatever. And then it'll have some kind of content body that usually identifies the client by some kind of ID. And then it has the data payload. So that could be a bunch of different things. It just depends on what kind of API you're using. The server will receive that message. The server will process the message just like the standard API request. And then the server will send the response. For a connection response, it's usually some kind of confirmation of the authorization along with the transformation of the data for the client. Then the server will wait for a little bit while the client receives a message, and the client will process the message, and then we'll just go do that over and over again. And that's all WebSockets really are. It's just that over and over and over again. But it's really cool because there's less waiting, less authorization, less validation, for the client and the server as far as security goes, because they've already done that in their initial connection. Try to make this project super accessible for newer programmers as well as intermediate ones. I've tried to make this base structure super easy to download and use. You can of course set it up manually if you'd like, but the documentation here is pretty clear. It's pretty short. You're definitely going to want to make a virtual environment, as you always should. And then you just download the requirements up text. You should take a look in there to make sure what you're downloading. And then you just check out the base structure branch, and then you use this command to run the Python server. And so the tutorial, little mini series that I plan on doing here, I'm not going to go over too much the base, HTML and CSS, but I'm not going to write it all from scratch. So I provided those files for you. They are complete, and also the main branch the charts branch, maybe the main, is also complete as well. But if you're just looking to find an easy place to start where you have, the basic structure of the project set up already, it's not super complicated, but there's a lot of moving parts, and that helps a lot. So yeah, look out for videos over the next couple of days, guys. I'm pretty excited. Thanks.